Look, the 5 gigahertz ceiling wasn't some calculated corporate choice. It was a physical ultimatum that Silicon Valley has spent a decade trying to hide from you. Think back to the early 2000s. I remember the roadmap. I mean, we were promised 10 gigahertz processors by the end of the decade. It seemed like an inevitability, right? A simple straight line of progress. But look at your workstation today. You are likely staring at a chip hovering somewhere between 4 and 5 gigahertz. Why? Because the heart of the machine has reached a dead end. We have been sold the illusion of progress, whilst the core clock speed has stayed essentially frozen for nearly 15 years. You see, instead of giving you the raw speed you were promised, the industry just pivoted. They started shoving more cores into the same space and calling it multitasking. They started talking about efficiency and thermal envelopes, as if those were the metrics we actually cared about in the era of peak performance. It is a brilliant bit of marketing misdirection. I mean, when you cannot make the car go any faster, you just tell the customer that it now has 16 wheels. But deep down, you know the truth. The single-threaded performance, the raw velocity of a single operation is hitting a wall made of heat and leaking electrons. At these frequencies, silicon begins to act less like a conductor and more like a heating element. It is quite literally too hot to handle. For the last decade, we have been living in the shadow of that failure, watching marketing teams wrap incremental gains in shiny new packages to distract us from the stagnant heart of the silicon. For decades, we were all fed the gospel of Moore's Law. It was a predictable, exponential climb where every 2 years our machines would double in speed, whilst shrinking in size. I mean, the industry promised us a world of infinite compute, a world where software would never outpace hardware. It was a brilliant era of progress, one that felt almost inevitable. But as we approach the 1 nanometer scale, that trajectory hasn't just slowed down. It has hit a physical limit, a literal barrier known as the power wall. Look, to understand why your next laptop might not actually feel that much faster than your last one, you have to understand the daunting reality of what is happening at the atomic level. Think of a transistor as a gate, a gate that controls the flow of electricity. As we make these gates smaller and smaller, the barriers between them become impossibly thin. We have reached a point where we are fighting quantum tunneling. I mean, it's a phenomenon where electrons literally leak through the gates because the walls, they are no longer thick enough to hold them back. It is quite literally like trying to hold water in a bucket made of tissue paper. This leakage creates a massive amount of heat that would melt a traditional chip if it were pushed any harder. We are no longer just fighting engineering hurdles. We are fighting the fundamental laws of physics. However, there is one detail the silicon giants have been desperately trying to keep under wraps as they pivot their entire business models. And that is where the story takes a much darker turn.
To solve the heat problem, designers didn't actually find a better way to cool the chip. They just found a way to stop using most of it. It's a concept known as dark silicon. At any given moment, whilst you're browsing the web or editing a photo, up to 90% of your processor might be completely powered down. It's just sitting there, cold and useless. Look, think of it like owning a bloody massive 16-cylinder engine, but the manufacturer has rigged it so you can only ever use 2 cylinders at a time. The other 14? They're just there to absorb the heat so the whole thing doesn't explode in your face, mate. That's a clever, somewhat cynical workaround that's fundamentally changed the gadgets you buy, This has triggered the end of the general purpose era. For decades, you could throw any task at a CPU, and it would crunch the numbers through sheer brute force. But those days are gone. Now, engineers are moving toward system-on-a-chip designs, or SoCs. You've seen the marketing for this. Apple, Intel, Qualcomm, they're all doing it. They're baking specific blocks for specific tasks directly into the silicon itself. There's a block for video, a block for AI, and a block for security. On the surface, it looks like a win for efficiency, right? Your battery lasts longer,
Your 4K video renders faster. But there is a much more daunting reality beneath the hype. This shift is actually a brilliant excuse for total ecosystem lock-in. By moving everything into one unrepairable slab of silicon, the manufacturers have effectively implemented hardware-level DRM. You can't upgrade your memory anymore because it's part of the chip. You can't swap a failing component because the entire system is a single proprietary black box. It's the ultimate corporate dream. They've traded the freedom of general-purpose computing for a walled garden where they hold all the keys. They've reached the silicon ceiling, and instead of breaking through it, they've decided to build a cage out of it. But here's the thing. As the hardware becomes more locked down and specialized, a new and even more invisible layer of control is being quietly integrated into the very devices you hold in your hand. This isn't just about heat or physics anymore. It's about the software that decides what your hardware is actually allowed to do. Look, we are moving from an era of computational freedom to one of optimized constraints. For decades, you see, the goal of silicon was power, raw, unadulterated power. You bought a machine and it was a blank canvas. It could crunch through any task you threw at it. But honestly, look closer at the latest spec sheets. The dream of the general-purpose computing, it's quietly dying. I see a shift in philosophy here that should quite literally worry you. Your next upgrade won't feel faster because the CPU is fundamentally better at math, right? It will feel faster because the hardware has been meticulously tuned to track your habits, narrowing your workflow into a predictable, profitable lane.
The silicon ceiling is not just a limit of physics anymore. It's the birth of a more controlled, less creative digital future. You see, Silicon Valley has realized they can't give us more speed, so they're giving us guardrails. They're building specialized engines for the things they want us to do, like consuming streaming media or running proprietary AI models, while leaving the tasks they can't monetize to rot. It's brilliant engineering, used for a daunting purpose. We're trading the open, modular nature of the PC for the slick, lockdown efficiency of a smartphone. I have to ask you, is the trade-off actually worth it? I mean, is a laptop that's 2 millimeters thinner really worth losing the ability to upgrade your own RAM or replace a dying battery? Is a slightly more efficient video encoder worth a machine that treats you like a guest rather than an owner? We are letting the tech giants convince us that these constraints are features, but in reality, they're chains. We're reaching a point where the general-purpose computer will become a relic of the past, a tool for the elite. Meanwhile, the rest of us are pushed towards specialized glass slabs that we can't fix and we can't truly control. I think it's time we stop being distracted by the shiny aluminum finishes and start demanding modularity again. We need to support the companies trying to break this cycle before the ceiling becomes a floor we can never stand up from. If we don't fight for the open machine now, we might find that our next upgrade is the last one we are ever truly allowed to own.